Okay, final example here. It says find the points on the curve y equals x to the fourth minus 6x squared plus 4 where the tangent line is horizontal. Okay, now this is going to be an application of a derivative. And we've already established in other lessons that the first derivative of a function is the slope formula for that function, right? And if we know the x coordinate of the point we're dealing with for the point of tangency, we substitute that x point into the slope formula to find out what the actual slope is at that moment, right? If we want the tangent line to be horizontal, that means that slope is equal to 0. Okay, a horizontal line has a slope of 0. And if the slope equals 0, that means that our slope formula should equal 0. We're trying to find the x values where that occurs. All right, so the technique here to find where the tangent line is horizontal, start with the function and do the first derivative to create that slope formula. So y prime, which is also the slope formula, you might call it m, just to identify that for yourself. It is a power function just like the last problem, and I'm going to get Logan and Claire to do this one since they didn't answer the last one. What's the derivative of x to the fourth? 4x cubed, and that was, I'm going to call Claire on that one. Hang on a second. Hello? Yep. Okay. Trainer Tyler. All right.
Can I after this, bro?
Yep. All right, Claire did that. Logan, what about minus 6x squared?
Minus 12x.
Minus 12x. And back to Claire, what about plus 4?
0.
0. Perfect. All right. So 4x cubed minus 12x is the first derivative of this function. And again, I want the tangent line to be horizontal, which means the slope equals 0, which means here's my slope formula, 4x cubed minus 12x. I want to set that equal to 0. And I want to solve that. Now, I may or may not be able to solve that algebraically. If I can solve it algebraically, I'd like you to do it that way. Otherwise, use a calculator. Graph this and see where it crosses the x-axis. All right. But in this case, 4x cubed minus 12x, I can factor a 4x out. 4x squared times x squared minus 3 equals 0 is the factored form. That means that 4x times x plus the square root of 3 times x minus the square root of 3 equals 0. You want to factor it as a difference of squares. Even though 3 isn't officially a perfect square, the square root of 3 times the square root of 3 makes 3, so I can treat it like a perfect square, right? All right. That gets me down to 3 linear factors. So either factor 1 equals 0, or factor 2 equals 0, or factor 3 equals 0. And all I have to do is solve each of those individually. We can see that this one's going to be x equals 0, this one's going to be negative the square root of 3, and this one's going to be positive square root of 3. It says find the points on the curve. Now, x represents the x coordinates of the points on the curve, right? Right. So the points we're looking for, 0 comma something, the square root of 3 comma something, and negative the square root of 3 comma something. How do I find the somethings? Where do I go?
Y equals mx plus b.
No, if we're trying to find the equation of the tangent line at those points, then we would go to y equals mx plus b. I want to find the actual points on the curve.
Plug it into your first equation.
My first equation. This is the curve right here, right? So if I want to find points on the curve, I substitute my x values into the x's there to figure out the y values, right? I would probably, since I'm trying to evaluate 3 different values here, I would probably go with my calculator. X caret 4. And again, anytime you do caret 3, 4, whatever, it puts you up on the power level. Press to the right to get back down to the normal level. Minus 6x squared, and then plus 4. And then I'm going to go to my table and just enter my 3 numbers. I'm going to type in 0. What do I get when I put in 0, by the way? Before I even type it in my calculator? Right, 0, 0, 4, right? It should get 4, right? So that also maybe can help me determine whether or not maybe I typed it in right. Okay, it's not foolproof, but it's helpful. I can also type in right here, I can type in square root of 3. It'll approximate the square root of 3, but you can type it in. I can also type in negative square root of 3. And we get 4, negative 5, negative 5. So those 3 points lie on this curve, and the tangent line for all 3 points will be horizontal. Horizontal tangent line means that the tangent line is flat, right? All right, let's take a look at the graph real quick and just to see. I'm going to set my window, I'm going to go from -3 to 3 on x. And let's go from let's go -10 to 10 on the y. All my values lie between -10 and 10 for y and between -3 and 3 for x. Hit graph, and let's just take a look at what happens. Okay. If the tangent line's horizontal, y equals 4 and y equals -5 is what the tangent lines will be, right? So take a look real quick. If I type in on the second equation y equals 4 and the third equation y equals -5, let me change the color. There we go.
You have to press that, right?
Enter. Yeah. There we go. Hit OK. Notice there's y equals 4, there's y equals -5. Notice the horizontal tangent lines occurring at those points, right? If I type in calculate value, and I type in the square root of 3, notice there's that point right there where that horizontal tangent line occurs, right? Right, so that kind of verifies, that's a visual verification that we got everything correct here. But notice what occurs at those tangent lines. So let me just erase those tangent lines real quick. Regraph. What's happening at those tangent lines? Where the tangent's horizontal. What's happening here and here and here?
It's turning and going.
It's turning and going the other way, right? It's hitting a low point, it's hitting a high point in its area. Okay, something we do in calculus, a technique that we use in calculus to find maximum and minimum values of a function is using a derivative, finding where the tangent line is horizontal. That's a place where a bottom or a top of a function can occur. Okay, we did optimization problems in geotrig using algebraic techniques. In calculus, we're going to use calculus techniques. It's much more efficient. But just know that's where we're going with this. But in a case like this, find the points. Points are x, y coordinates. Calculus gets you the x's, and then substitution gets you the y's to find the points on the curve where those tangent lines occur.